Good afternoon, everyone, and welcome to DEV317. Thank you for joining us. My name is Shayan Biswas. I'm a Senior Product Manager with Amazon Web Services in the management tools space. Today, I've been joined by Eric Gifford and Brad Davidson from Cambia Health Solutions. We are really excited to be here at reInvent. I hope you all are having a great time too. Did you guys all see the semi roll-in at the keynote stage? Yeah, that was fun. All right, so in this session, I am going to show you how you can use various management tools offered by AWS to automate and scale administration of your infrastructure on AWS. So let's get started. What can you expect from this session? We will walk through some common scenarios, common use cases. I'll then show you how you can apply management tools offered by AWS to address these use cases, these scenarios. There'll be quite a few how-tos, demos, and working code examples that you can take back home tonight and try out. We'll also hear from Eric and Brad talk about their implementation of some of these tools at Cambia Health Solutions. Finally, as an IT administrator, your objective is to unbottleneck yourself. You don't want to be a barrier to developer productivity and agility. And that's precisely what I'm going to show you today with the help of management tools. And in doing so, I'm going to talk about two individuals, Adam, who is an IT administrator, and Daisy, who is a developer. So are there any Adams or Daisies in the room here? I don't see any hands go up. Well, these two are totally made up, fictional characters, so no resemblance is intended. So that's my disclaimer. With that out of the way, let's think from Adam's perspective. Adam, who's an IT administrator. What does he really want? He wants to have control over his infrastructure. He also wants to gain deep visibility within his infrastructure. So who is doing what? Who accessed what kind of resources within his infrastructure? He, of course, also wants his infrastructure to be secure. He does not want it to be compromised in any way. In addition, he is subject to regular audits, and Adam's company also needs to comply with industry regulations. So he deeply cares about audit and compliance use cases as well. Now let's switch our roles a little bit and start thinking from Daisy's perspective. Daisy, who is a developer, what does she really care about? She wants to be able to quickly access resources and services provided by AWS and use those services to iterate and develop innovative applications for her business. And she wants to do it in a simple and easy manner. She does not want to jump through too many hoops. Now, if we take a step back and look at these priorities, we'll notice that there's potentially a chance for conflict. Well, not quite. What I'm going to show you today is how Adam and Daisy collaborate with each other using management tools and walk away with a smile on their faces. So I've been talking about management tools. So what are the services we are going to see today, walk through today? AWS CloudFormation, AWS Service Catalog, AWS CloudTrail, AWS Config, and Amazon CloudWatch. These are the services I'm going to be talking about today. Now, just by a quick show of hands, have any of you used any of the services listed here? Just any? All right. Wow, so many hands up in the air. These are popular services. So what I am going to do is show you how you can use a combination of these services to manage the entire life cycle of your infrastructure on AWS. So let's get started. These services provide Adam a range of capabilities. With CloudFormation, Adam gets to represent his infrastructure as code, and that enables him to provision his infrastructure with speed and with agility. Service Catalog extends that and enables Adam to provide self-serve capabilities to Daisy. Now, let's also talk about delineated access privilege. The permissions and access privileges that Adam, as an IT administrator, needs to provision and manage his infrastructure is quite different from what Daisy needs to build an application and run an application within AWS. So we'll see how Service Catalog enables Adam to maintain that delineation. Once the infrastructure is provisioned, there's also need for Adam to maintain visibility and control over his infrastructure. And that's where CloudTrail, CloudWatch, and Config come in. With these services, Adam can define guardrails that enable him to ensure that Daisy stays within the defined path. So we'll consider a typical day in Daisy's life. So she walks in, she's working on developing an application, and she needs a dev stack for that. So in a typical day, she reaches out to Adam and asks for a dev stack. Adam says, all right, yes, let's provision it. And he piecemeals together a LAMP stack using the tools provided by AWS, the Management Console, SDK, or the CLI. So that works fine. But Adam potentially does not have just Daisy in his organization. He probably has more developers. Maybe 5, maybe 10, maybe hundreds, or maybe thousands. Even if he has only 5 or 10 developers in his organization, he wants to be able to be in a position that he can scale up when more developers join his organization. So how does Adam achieve this? Adam relies on AWS CloudFormation for it. CloudFormation enables Adam to represent his infrastructure as code. Now that's really powerful. With this capability, now Adam can employ his usual development tools for code reviews, updates, and source control. In addition, CloudFormation allows Adam to templatize his infrastructure. So he provisions one LAMP stack for Daisy. He can continue doing that for multiple developers in his organization once the template is set up. And very recently, CloudFormation added support for YAML. YAML's a more human-friendly, easy-to-read, descriptive way to represent infrastructure. So let's see a quick comparison between JSON and YAML. A lot fewer braces, fewer quotes, easier on the eye, and simpler to read even for someone who is not very deeply technical. So that's a benefit he gets from CloudFormation. So we are going to see a quick demo of how Adam uses CloudFormation. So for this, we are going to jump into the CloudFormation console. And we'll go on and create a stack. Let's do that. And we'll select one of the existing stack templates available. So LAMP stack, multi-availability zone stack, so it's highly resilient. And we'll use a Visual Surface CloudFormation designer to visualize what resources are going to get provisioned. So there's an auto-scaling group with multiple web service. There's an elastic load balancer balancing traffic between multiple instances, and a backend, a MySQL backend with associated security groups with it. So that's great, but Adam may also want to parameterize certain attributes of this template so that when he creates the stack for other developers, he has some configuration ability. So he's going ahead and removing the larger instance types. This is a dev stack, remember. So he does not want Daisy to be creating very beefy instances. Smaller ones are fine. So with that done, let's save the template on our local drive, give it a proper name. And with a few clicks, we save it. It's on my disk. There it is. And now we are ready to create the stack, so quickly click on the button over there. And it gets uploaded to an S3 bucket as well, which CloudFormation has access to. So next, we'll configure some of the stack attributes. So give it a proper name. You can see only the instance types that Adam had selected are available here. Select a key pair. Now, Adam does not want to open the instances up to the world, so he's specifying a CIDR range there and 2 instances to start off with. Cost tags enable Adam to track costs associated with this tag, so he applies a cost center tag for Daisy. And with that, we are almost set. Review all the details. That's it. It's ready. And all the resources get provisioned within a matter of a few moments. We see all the events flow through. There it is. The stack is now ready. So that's great. Adam gets to templatize his infrastructure. He gets to represent it as code. But there's still one touch involved. Daisy and other developers still have to contact Adam to provision this stack within their account. So how about enabling self-service for Daisy? What if Daisy herself could request for a stack and provision it, and at the same time maintain the delineation of access privileges we talked about earlier? So for that, Adam uses Service Catalog. Service Catalog provides capabilities to Adam to define a portfolio of IT products. Now, what's an IT product? In this example, it is the LAMP stack. It could be a Docker environment. It could be any other application stack that you desire. Adam uses CloudFormation, as we saw, to define these products and then makes them available on the product catalog. Finally, Adam adds permissions and constraints on this catalog. So how many instances of a certain product, a LAMP stack gets provisioned, he can control that. He also can specify an IAM role, the set of permissions that Service Catalog should be using to provision this product. Now, the thing to note here is that Daisy does not need to have access to those permissions. Service Catalog maintains that. And once these products are available, Daisy browses them, selects them, and launches them on her own. And both Adam and Daisy get notified as these products get provisioned. So quick wrap-up of what Service Catalog is doing for Adam and Daisy. It is enabling Daisy to self-serve her infrastructure needs. Adam gets to define approved products, best practices with the products he's adding to the Service Catalog. And then a key interesting factor about Service Catalog is that he can specify tags on the resources. And these tags cannot be changed by Daisy. So if you want to track costs associated with these products, it's simple and easy to control. So we'll see a quick demo of how Adam uses Service Catalog and Daisy uses Service Catalog as well. So for that, let's get into the Service Catalog console, and let's create a portfolio. Give it a proper name. So we'll call it a dev portfolio because it's a set of products for developers. Give it, and the owner is Adam, so that's what we enter in here. Now, the portfolio is created, but it's empty. There are no products in it. So we'll go ahead and add a product, the product we just defined with a CloudFormation template, the LAMP stack, and provide a description for it. Adam's creating this product, so he enters his contact information so that if something goes wrong with the LAMP stack, it does not get provisioned properly, Daisy can reach out to Adam. Or the descriptions and move forward. And now it's the time to select the template that we saved on the local drive. We'll go ahead and select that. Provide a version, so Adam can version this. So if in the future he wants to add certain instance types, for example, he can provide another version, v2, with additional instance types in this product. We review all the details, everything looks good. Let's create that. Now the portfolio has one product. Next thing that we are going to do is add constraints to the product. So in this case, we select the product, and we are going to add a launch constraint. And this constraint is going to specify the permissions the IAM role service catalog should be using to provision this product. Just to reiterate, Daisy does not have access to this role. She does not have to. And with that, the constraints added as well. The last step remaining is to provide access to this portfolio of products. So Adam goes in, adds the developers group, because it's a portfolio of products for developers. And he can specifically select Daisy as well to grant her access. So there it goes. So now we are set and ready. So we'll jump over to the experience that Daisy sees. So let's log in with Daisy's credentials and see what she gets to browse in the catalog. So in this case, she sees the LAMP stack, selects that. She can provide any name she desires, so that's the flexibility she now has. Selects the version of the product that she wants, the launch configuration, and let's move next. The next step, Daisy gets to provide additional details about the stack. So she gets to choose the DB password, database password she wants to use, set of IP addresses there, and you can see she's restricted to only certain instance types that she can provision. She just cannot go about selecting anything. That's it, and she provides the tag. And let's move forward to the next step where we see there's a possibility of setting up an SNS topic to receive notifications. We'll skip that for now and launch it. That's it, straightforward, simple. The stack is now getting provisioned. So that's that straightforward. So we saw how Adam and Daisy use CloudFormation and Service Catalog to provision resources within AWS. Now, Daisy continues to use these resources, modify them, change them to build her application. So how can Adam gain visibility into what's going on into his account? So for that, he relies on CloudTrail, Config, and CloudWatch. Let's take a deeper dive into each of these services. So with these services, CloudTrail and Config, he gets to gain visibility into his infrastructure. So CloudTrail logs the API activity that Daisy generates. So Daisy uses the various tools available to make API calls, modify resources. Those get logged by CloudTrail in an S3 bucket. These also get delivered to CloudWatch. So with CloudWatch, Adam now can define alarms and metrics over these API calls as well. Now, API calls are getting logged by CloudTrail, but what's the change that is happening? That gets recorded by Config. Config continuously monitors the configuration changes to resources in Adam's account. This helps Adam also get an inventory of resources within his account, and not just current active resources, but also deleted resources. So if Daisy spins up an instance, deletes that, he can go back into config and see what instances were spun up by Daisy. Adam also receives notifications whenever configuration changes are detected by config. Now, what are config rules? Config rules is a set of capabilities which enable Adam to translate this deep visibility provided by config into awareness and action. So let's dig a little bit deeper into config rules. With config rules, Adam can define his policies and guidelines. Then, as configuration changes are detected, they are evaluated against these policies and guidelines. There are a set of pre-built rules that are available to Adam. So Adam does not have to write any code. He can just select one of those rules. Or, if he so chooses, he can go ahead and write custom rules according to his needs using Lambda function. With this, Adam also gets notified when any of his rules are violated. And he gets an access to a dashboard where he can see which of his rules are not compliant and what resources caused those rules to go non-compliant. So this is a quick schematic of config. There are resources in Adam's account which are being continuously recorded by config, normalized into a standard format, what we call as a configuration item. Then the rules get applied on top of these changes. If any changes are found to be non-compliant, notifications are sent. Adam gets API access to this data as well, and this information gets deposited in an S3 bucket too. So now we'll see a quick demonstration of a scenario. Let's say Adam's interested in finding out what's going on in his account, and he wants to know, he's curious, what Daisy has been doing. So for this, we'll get into the CloudTrail and config consoles. We'll assume that both of these services are already set up. Simple to set them up, but we'll not spend time doing that right now. So let's start by getting into the CloudTrail console and look up some activities that Daisy performs. So let's select username and enter Daisy's name in there. Hit enter, and we see a list of events that show up. And the interesting bit is there's some activity that Daisy has been performing on security groups. Let's dig in deeper. So she has revoked and added new ingress inbound rules on the security groups. So that's slightly concerning. Let's look at the details in config. So jump over to the config timeline. We see that there are changes and associated events that resulted in these changes potentially. And what are those changes? Let's see the details. And we see that there was a specific CIDR range initially mentioned, and now she has changed it to /0, opening access to that instance to the entire world. You can also look at the relationships and see which instances the security groups attach to. So these are the instances which are potentially now vulnerable. So that's great. Adam's curious, so he was able to go in and figure out what Daisy was doing. But Adam can't be expected to do this 24/7 for all of his developers, can we? No. So what about means through which Adam can fix this automatically so that he does not have to monitor this activity? So for that, let's see how Adam uses config rules. So for that, we'll jump into the config console and look at rules. So we'll click on the rules on the left-hand navigation. These are the set of pre-built rules which are available to Adam. He does not have to write any code for it. The one he is interested in is restricted SSH. This would identify any security groups which have /0 access added to them. Immediately we see there are certain security groups which are not compliant. And let's browse to the one which Daisy just modified. There it is. We'll go in and look at the details of the security group. And there it is. So the associated events you can see there, right down there. She added and removed certain access privileges there. Now, how about the auto-correction piece that I was talking about? So the next demo we see, we will provide Adams the mechanism to define those auto-correction abilities. So first, we'll look at config and see which SNS topic is configured for AWS config. So config topic, aptly named, is the SNS topic. That's great. Let's now move over to the SNS console. There's the SNS console, and we are going to look up SNS topics under it, and there's the config topic. Let's select that. And what we are going to do for Adam here is create a subscription. And this subscription is for a Lambda function. So whenever a notification is received on this SNS topic, this Lambda function gets fired. And there he locates it, fix security groups, appropriately named. That's that. So what does the code underneath in the Lambda function look like? Let's take a quick look. So line 6, that's the entry point for the Lambda function is the handler. We first perform some sanity checks. Then we ensure that it's a compliance change notification, line 17. We ensure that it's coming from the restricted SSH rule that Adam created previously. Then we also check whether it's a non-compliance notification. That is, the rule was violated. This notification was sent because the security group has a /0 inbound rule added to it. With that verified, we invoke another function. That's called revoke security groups ingress. Let's look at the code for that. Now, we are sure that there's a /0 inbound rule added to this security group. So we'll add the parameters and simply revoke that inbound access. That's it. So anytime Daisy goes in and modifies the security group, config detects it, runs the rule, finds that it's non-compliant, sends a notification, Lambda function runs, and fixes it. And eventually, it gets fixed in the rule itself. It shows up as a compliant rule. Now, there's one way of fixing this, but what if Daisy finds out that Adam set up this rule and he is auto-correcting the security groups? And she's really annoyed, so she goes in and turns off config. What happens then? So there's multiple mechanisms that we provide Adam to react to such situations. So let's talk about CloudWatch a little bit. I'm going to give you a brief overview of the service. So with logs, Adam and Daisy can deposit application logs within that, and then both Adam and Daisy can define metrics and alarms on top of it. And events allow Adam and Daisy to react to changes happening within their infrastructure and take action. So let's take the scenario where Daisy has turned off config. What can Adam do? For this, let's get into CloudWatch Events and select Events from the left-hand navigation and add an event rule, create a new event rule. And what we are looking for is a specific API action. The specific API action here is top configuration recorder. So we'll look for API calls. That's the kind of event we want to tap into. Then select the service we are interested in, not everything, but config. So let's select that from the list. And not just about any API action, the specific API I just talked about. So let's go in and select stop configuration recorder. That's it. And now we'll add a target. In this case, Lambda's default, a Lambda function is what Adam selects. So this Lambda function will be fired whenever Daisy calls that API through the console, CLI, or SDK. Confirm that, provide some more details for this rule, so name it properly. Call it restart AWS config. The description, and create the rule. That's it. Very simple. Now, the rule is created. Let's look at the code within that Lambda function that Adam just configured. This is, again, a very straightforward function, just the handler. And within the handler, what we are doing is providing a name for the config recorder and calling start config recorder. That's it. So Daisy turns off config. The event gets delivered to CloudWatch Events. The Lambda function gets fired, and it restarts AWS config. There it is. Daisy's bad luck. She can't really get her way out of this. So we have seen how Adam and Daisy use the management tools to collaborate and essentially walk away with a smile on their faces. So with this, now I'll hand over to Eric and Brad to walk us through their solution, their implementation. Off to you, Eric. Thank you.
Thank you, Chayan. Very happy to be here and share our story with you. So nearly 100 years ago, a group of physicians in Pierce County, Washington, formed the United States' first employer-based health plan. That company, the Pierce County Medical Bureau, eventually became the Regents Blue Cross Blue Shield brand, and it's now a Cambia Health Solutions company as well, and also a member of the Blue Cross Blue Shield Association. So today we're focused on transforming healthcare to become person-focused and economically sustainable. We're helping people make smarter healthcare choices. We're arming you with cost transparency tools so you can shop for the quality and cost of care that you're looking for. We're providing wellness rewards platforms and also microservices based on AWS, data science capabilities, et cetera. So clearly we need to comply with HIPAA law. Being in the healthcare industry, we need to keep your data very, very safe. And we're also embracing DevOps to do that. We feel that we can be more secure in the AWS cloud using DevOps methodologies than we can in our own data centers using some of the legacy IT tools. We think automation's a wonderful way to reduce risk. We think that allowing this stuff to be scripted and tested and run through CI/CD pipelines is a fantastic way to deliver secure services. And we are focusing our security resources up the stack and allowing AWS to do what they do well with the shared responsibility model. There's really a lot of power in that for organizations to not focus on patching OSs and really align with serverless and managed services. And we are very much wanting to implement guardrails and not gates to allow our business to move as fast as it wants to in a secure manner. And so much of what Cheyenne was talking about, we're doing as well. So let's show you what we're doing to continuously monitor our environments. So we have some CloudFormation set up that lays down CloudTrails in all of our AWS accounts. Those CloudTrails point at a centralized InfoSec S3 bucket. And when those log files land, they fire an event notification to an SNS topic. And that event notification also wakes up our Lambdas and fires them. Each Lambda today picks up the log file out of this S3 bucket, unpacks it, and runs the logic in the Lambda against it. In some cases, we may just log it. In some cases, log and alert. Some cases, log, alert, and fix. So here's some examples of what we've implemented. We know immediately when multi-factor authentication is disabled on an account. We know immediately if an unauthorized region is being used. We know when logging is turned off. And the sky's the limit here. We can also do things like monitor for encrypted volumes. We can monitor for the dedicated tenancy that we require in healthcare, et cetera. So this is a bit of a good start, right? It's simple. We've got independent Lambda functions, potentially not well optimized. We need to customize each Lambda with code as we evolve it. And also a lack of context in the raw CloudTrail event, kind of which application workload is this and who is this user, what department are they in, et cetera. So we'll keep building. We're decoupling and scaling for efficiency. We want to really only unpack that CloudTrail file once and then put the relevant parts back into CloudWatch Events. We want to add context so that we can make better decisions on the fly in real time. And then have the flexibility ultimately to tune based on workload, based on DevOps team, based on CI/CD pipeline that's being used. Those can be at different states of maturity and we need to accommodate them. So here's what that new architecture looks like. The left-hand side's very, very similar, right? We land our logs into our central InfoSec log bucket. The SNS topic works as a notifier for our Lambda. That Lambda now just pulls down that log file once, unpacks it, and puts those events back into CloudWatch Events for us. The next tier of Lambda enriches those events with our organizational context, and then we can run our signatures against it using DynamoDB. And then another tier of Lambdas that are more specialized around logging, alerting, and also fixing. So what do we have here? We can know a lot more about the workload and the user and what's supposed to be going on. We can have a centralized policy and signature database rather than having to do that in each Lambda. Lambdas work a lot faster, right? So, when we're optimizing there, we've got our Lambda cost per month down to $2.60. So, we win there. It is relatively more complex to use, support, and maintain. And then we do need to get it over to ops and let them have the security operations group and let them run it. So we do ultimately need a UI for analyst workflows, reporting, tuning of our policies. We would like to see a simulation mode implemented so that we can safely test against the production logs without fear of impacting anything. We need some sort of sync job to keep our enrichment database current, potentially a nightly pull down or something similar. We'd like to see integration with ticketing systems so we can cut a ticket and make sure that that ticket gets closed when there's something that we've seen that needs to be addressed. applying secure configurations at instantiation of an object. So think of an S3 bucket. There's some bucket level policies there that need to be laid down. So we can do that when the bucket's created. And then also we're headed towards using threat intel and VPC flow log correlations so that we can know when something that comes out of the threat intel space that has poor reputation, if that's initiating connections into our environment, we would very much like to be blacklisting those in real time in an event-driven manner. So this is where we're headed. And we'd like Brad to give you a demo of what we have today.
Thanks, Eric. In the full spirit of Vegas gaming, I am going to attempt a live demo here. Give me 1 second to get logged in. All right, so as you can see, I'm logged into one of our AWS accounts here. And I'm going to be showing how Canby Health Solutions is using AWS Lambda with CloudTrail and CloudWatch Events to automate the security of our accounts. This is sort of the phase one that Eric demonstrated in his slides just a moment ago. So I'm logged into one of our AWS accounts here. Thanks. And as you can see, we're looking at a list of the Lambdas that are currently defined in this account. You can hopefully tell based on the naming convention and the description that some of these Lambdas are hooked into CloudTrail or CloudWatch Events, while others are utility functions that integrate with third-party vendors or other AWS services that I'll speak about in a moment. Some of these Lambdas simply watch for particular events and notify our staff if anything questionable occurs. Things like MFA being deactivated, critical API methods being called in particular accounts or regions, other things like that that Eric talked about. Other Lambdas actually take action to remediate, much like some of the Lambdas that Cheyenne demonstrated a moment ago. So I'll show one of those now. As Eric mentioned, we have all of our various accounts plugged into CloudTrail that are dumping all their CloudTrail events into a single S3 bucket. In this demo, we're doing everything within a single account, so it's not entirely representative. But we currently have a Lambda running that monitors that central S3 bucket, and it watches for configuration changes. And if that Lambda detects that someone has done something like stopped the trail, disabled multi-region, deleted it, etc., it'll actually call the CloudTrail API to restore our desired state. So I'll demonstrate that here by disabling the global trail option, and I'll even go ahead and turn it off entirely. And then we'll go ahead and turn off. Off and off. All right. So I should note that CloudTrail batches up events over a window of time, usually about 5 to 10 minutes. So there's a slight delay before our Lambda will get notification that anything has happened. If we get the notification that CloudTrail has been tampered with, or we can feel pretty confident that the Lambda has turned it back on again immediately, we would still launch an investigation, an incident response process to figure out why it was turned off, ensure that nothing else occurred while it was out of commission, et cetera. There are other tools you can use, assuming they're still turned on, like AWS config, to maybe take that evaluation process and streamline it a little bit. But anything along these lines would definitely trigger an incident response process. And this is one of the reasons that we've sort of centralized things into one account. While folks might have access to tamper with CloudTrail in their account, the logs are going into our S3 bucket, which is owned by our account, which has a much higher level of security. It has much more isolation so that folks can't go in and actually muck about with our S3 bucket or our Lambdas that are watching that bucket. I will also note that there are some things that we can't catch right now. For example, if the trail is updated to point at a different S3 bucket, the event noticing that change is actually delivered to the new bucket, not the old one. So that's a current gap. For that reason, we take a belt and suspenders approach and actually use a scheduled Lambda in our account to ensure that all the accounts are reporting in regularly. The Lambda on our side is still set to be notified when objects are uploaded to the S3 bucket, that CloudTrail is still configured properly in all the child accounts, et cetera. We can also look for unexpected CloudTrail API calls showing up in our CloudTrail to tell us that maybe a trail had previously been stopped or misdirected and now it's come back. So those are things that we can look for. So while we're waiting for that batch of events to be delivered to our Lambda, let's look at some of the things that we're doing with CloudWatch Events. CloudWatch Events are great for real-time remediation as they are delivered within milliseconds of the API call. Usually, sometimes it's a little bit longer, a couple seconds. Unfortunately, events are harder to centralize because all the various event rules and their targets, whether those are Lambdas or SNS topics or anything else like that, they all have to live in the same account. You can work around that by writing events through like an SNS topic that's in a different, like sort of chaining them across accounts, or by doing proxy Lambdas that would then trigger a Lambda, invoke a Lambda in a different account. But it's not quite as cut and dried as CloudTrail, where all it takes is a couple of clicks to configure a trail that points directly at someone else's S3 bucket. That is something we're looking at doing in the future. It's not currently operationalized yet. The CloudTrail thing is very easy to do. It's very easy to stamp out on another account with CloudFormation. So within our account, we have a couple Lambdas that are hooked into CloudWatch Events for EC2. We're using this to ensure that we don't start any instances that are in violation of our security policies or our BIA, such as those policies and requirements that require encryption for all of our ABS volumes, dedicated tenancy for all of our instances, et cetera. So I'm going to launch an instance here using a stock AMI. I'm going to launch it into shared tenancy without any volume encryption, and let's see what happens. So normally we would of course use infrastructure automation tools like Ansible to do this, but just for the purpose of the demo, I'm going to click through the manual launch process. Put in our dev, don't need a role. We will select an existing security group so I don't spam myself with a new launch rule. And let's go ahead and launch it. So just like anything, once you launch it, it goes into the pending state. After a few seconds, it should go into the running state. And this is where some of the variable latency around CloudWatch events can be a little bit interesting. Sometimes it triggers almost immediately. Sometimes it takes a little bit longer. But within a few seconds, you can reliably see that it will go from running to stopping to terminated. While we're waiting for this to finish its boot process and for us to get that event notification that triggers our Lambda, let's go look what we've got over here. So we are using it to do a couple other things. We'll come back here in a moment. So we're using CloudWatch Logs, the CloudWatch Logs agent on all of our EC2 instances. And we wanted a way to archive the events out of CloudWatch Logs into S3 for long-term storage and for ingest into our Elk stack. And we're using Kinesis Firehose to do this, to pull everything out of here, dump it into S3. And that requires configuration per log group. You can see there's a bunch of Firehose subscriptions over here for each of these log groups. Unfortunately, the filters that send events into Firehose need to be created per log group. So if you have a new log group that's created, say by adding a Lambda that started logging, or if you've got something else plugged in that starts creating a new log group, until you go in and set that up, you're not getting it a part of your archive. So rather than have to remember to set this up every time something creates a new log group, we've got a Lambda that runs automatically to ensure that All of our groups have Firehose subscriptions. I'm not sure if you can quite see the code sample here, but this is just using the standard, this is in Python, so it's using the Auto3 API, and it just runs and it takes a look at all the log groups that we have, and if they're missing anything, it also sets the roll-off time, so we don't have more data in there that we don't want, and it sets up the Firehose subscription. Let's jump back to EC2 here. Nothing like a live demo for a little excitement. Let's see what we've got for notifications here. So you see some of the other Lambdas have triggered off in the background here. While we were working on the stuff with Lambda and EC2, our Lambda did notice the batch of events got delivered to our S3 bucket, our Lambda was notified, and it actually noticed that our CloudTrail configuration was changed. And you can see it tells us which CloudTrail configuration and which account. It tells us who did it, and it tells you where they came from. This is all just configurable metadata that's been pulled out and dumped into a formatted string so we can easily consume from this notification. And if we go back to our CloudTrail, let's look at how it currently looks. So we can see that it's been turned back on. It hasn't yet noted that our multi-region was turned on. So again, event batching being what it is, we get different things at different times. And as things are noted, they're automatically remediated. Let's see if this one's kicked off yet. Nope. All right. That's the fun of a live demo. So these are just a few examples of how we're using Lambda, CloudTrail, and CloudWatch Events to automate our security stack. And as we continue to build, our event pipeline will become more streamlined and capable with hooks into additional systems for event metadata enrichment, more automated remediation, active hooks into other accounts, et cetera. This is the sort of automation integration that's going to help us as a security team keep up as our AWS account footprint grows. So whether we have one account or 1,000 accounts, 100 customers in there, or 1 million using that, our security scales automatically. Thanks for watching.
Thank you, Eric, and thank you, Brad. That was a great demo. So you have seen how some of these management tools, management services can be put to use, and this was a great example at Cambia Health that you saw in action. Now, we have a set of partners who work with our services, so do go out to the expo today, check out. If you have any feedback or comments, that's my contact information. Feel free to reach out. And do remember to fill out the evaluations that help us improve our sessions over time. So thank you very much again for joining today, and have a great rest of the day.